Good afternoon, guys. This afternoon I'm going to solve a problem based on trigonometry identities. Before I do or I solve, I need to know my trigonometry relationship or identities. So without wasting of time, let's get started. One called reciprocal identity. Reciprocal identities. Reciprocal identities. 1. Sin theta is equals to 1 all over cosecant theta. 2. Cosine theta is equals to 1 all over secant theta. 3. Tangent theta is equals to 1 all over cot theta. 4. Cosecant theta is equals to 1 all over sin theta. 5. Secant theta is equals to 1 all over cosine theta. Then 6 cot theta is equals to 1 all over tangent theta. Let's continue. 2. Tangent and cotangent identities. Okay. Identities. Okay, let's continue. Number 1 is tangent theta is equals to sin theta all over cosine theta. 2. Cotangent theta is equals to cosine theta all over sin theta. So guys, let me explain one thing. As you can see, tangent theta, the relationship of it is opposite with conjunct or cotangent theta. So if you see properly here, for tangent theta, sin theta is all over cosine theta. So at the top sin theta, or in other words, at the numerator you will see sin theta, and the denominator you will see a cosine theta. So in cotangent theta, the relationship of, you will see that cosine theta will go up to numerator and the sin theta will come back to the denominator. So this is the one thing that we need to memorize whenever it comes to a problem that is needs these identities. And number 3 is called Pythagorean theorem. Pythagorean, Pythagorean, Pythagorean theorem or identities. Okay guys, 1 sin theta square plus cosine theta square is equals to 1. 2 tangent theta square plus 1 is equals to secant square theta. 3 1 plus cot theta square is equals to cosecant theta square. Okay guys, let's continue on. Another thing I need to let us know about the techniques or the skills that we need to know in order for us to solve trigonometry identities. So first, number 1 is finding and using a greatest common factor. Okay, two factoring using a difference of squares. And then 3 finding a common denominator. Okay, and lastly to the list, dividing by a fraction is the same as multiplying by each reciprocal. Okay guys, so this is what I'd like us to know. All of these identities where I was stated, we need to know those in order for us to solve trigonometry identities. And another thing additional with identities about the skills or the techniques on how you're going to tackle the trigonometry identities problem. We need these 4 steps, as I said already. Okay, so let's continue with our first problem. Our first problem stated here. Number 1, sine theta raised to power 4 minus cosine theta raised to power 4 is equals to sine theta squared minus cosine theta squared. So guys, let's prove this one. So first thing first, I'm going to prove that the left hand side must be equals to right hand side. Okay, before I do that, I'm going to solve at the left hand side to simplify down to make it equal to this sin theta square minus cosine theta square, which is right hand side. Okay, first thing first, I'm going to simplify this one further down. So if I'm going to simplify this, I'm going to apply the special product, which is, we are applying the algebra now. Special product of this equation. But if I simplify, it will going like this: sin theta squared open bracket sin theta squared close bracket raised to power of 2 minus open bracket cos theta square close bracket. Okay, let me explain this. Why am I applying this according to algebra rule? So as you can see, I was simplify this one, this 2 and this 2. Okay, in multiplication rule, and if I simplify this, for example, multiplication rule, anything raised to power of 1, 2, 2, 3, and in the power you need to add. So this is the law of algebra that I was applying here. So what do I mean by that? Product of the square, which is this one. If I apply x plus y, x minus y, which is equals to x square minus y square. Okay guys, this is what I mean about the special product, or in other words, the product of sum and the difference multiplication is equals to the two terms, which is two terms. This is the two terms I'm referring to it. Okay, so let's continue. Now I'm applying the product of sum and the difference, which is this one. As you can see, this one and this one is equals to this one is equals to this one, which is the two terms. This is the two terms and this is the two terms. Okay, and if I am simplify further down to apply the difference of sum and the difference of product of the sum and the difference, which is this one, then I'm going to simplify further down. It's like this: sine theta square plus cosine theta square close brackets multiply by sine theta squared minus cos theta squared close brackets. Okay guys, this is what I mean, which is the product of sum and the difference. This is the product, sum and the difference. Okay, sum and difference. So let's continue. but let me write first, I will explain. But sine theta squared minus cosine theta squared is equals to 1. Where did I get this? I'll go back to my trigonometry identities. So if I see here reciprocal, no. Tangent and cotangent, no. Pythagorean identities, yes. This one. So I'm applying this one. Okay guys, as you can see, I'm applying this one. Sin theta square plus cos theta square is equals to 1. Okay, which is this one. So now I'm going to apply this to simplify whole thing down to make it is equals to sin theta square minus cos theta squared. Okay, so if I place this one, that's rearrange in a manner, then I can do it like this. We know that this one is equals to 1. Okay, so if I state this way, 1 open brackets sin theta squared minus cos theta square. Okay, whole thing inside here will multiply with 1 is equals to whole thing here. Okay guys, don't confuse yourself. Okay, so if I state sin theta square minus cosine theta square is multiplied by 1 is equals to sin theta square minus cos theta square is equals to this one. I bring this one down so that we are proving to make it equal. Okay, so this is our final answer guys. This is our final answer. Let's continue. Okay, let's continue with our question number 2. Question number 2, 1 all over sine theta is equals to cot theta all over cot theta minus cosine theta. Okay, guys, let's prove this one again. Which one I'm going to consider and apply to make it either equal to right hand side or left hand side? I have to question myself which one I'm going to start first. Am I going to start at the right? Am I going to start at the left? Those are the kind of questions that will come into your mind. Then we will refer back to our rules here. This is our rules that I was talking about. Okay, guys, as you can see. So which rule here I'm going to apply? Dividing and using the greatest common factor, factoring using a difference of square, finding and common denominator, dividing by fraction is the same as the multiplying by its reciprocal. So which one I'm going to apply? So I'm going to apply rule number 1. Okay, so let's continue. Rule number 1. So I'm going to solve this way. And another thing, like I said, which one whether I'm going to start whether right or left. So in my case I'm going to start it right to make it is equals to left. Okay, so what is the relationship of cotangent theta in the numerator and denominator minus cosine theta? So I refer back to my relationship. Going to apply reciprocal? No. I'm going to apply tangent and cotangent? Yes. And Pythagorean identities? No. So I'm going to apply this one, guys. Cotangent. Okay. Okay, cotangent is equals the relationship of this, which is cosine theta all over sin theta. Okay, all over again below another another cotangent here, so I just apply the same relationship on top here. So cosine theta all over sin theta minus cosine theta, I just bring down. Okay, this is equals then copy everything down here. Cosine theta all over sin theta all over. Okay, below. Now I'm going to cross multiply. Okay, guys, cross multiply. What do I mean by that? Then refer the law of addition and subtraction. Okay, guys, so if I use a all over b minus c all over d, so if I cross multiply a minus a multiplied by d, which is ad, keeps the sign b multiplied by c, which is bc, all over b multiplied by d, straight bd. So this is the rule that I'm going to apply here. Okay, so as you can see here, another thing I need to explain here, same as addition, like I said, addition and the subtraction rule are the same. So if you compute it like a all over b flush c all over d, so if you multiply everything, AD flush, like what I did exactly same here, I'm going to apply with the addition here. Okay, b multiplied by c equals bc all over denominator multiplied by denominator, which is b multiplied by d, which is bd, same. So that is exactly I'm going to apply here. Okay guys, so as you can see, this one we all know that all over 1, so no need to write, we know according to common sense this is 1. Okay, so if I cross multiply, I will copy cosine theta, keep the sign, minus cross multiply cosine theta sine theta. Okay, cosine theta sine theta. Okay, all over sine, all over sine, this one, not this one, this one, sine theta. Okay, okay, all over sine theta. Okay, let's continue. Okay, and by continue, copy cosine theta all over sine theta. Okay, one thing, another thing. Now I'm going to apply the identities or relationship of this one. So what is the relationship of cosine theta? Now I refer back to my identities. Once again, am I going to apply reciprocal identities? No. Am I going to apply tangent and cotangent identities? No. Am I going to apply Pythagorean identities? Yes. So as you can see here, I'm going to apply this. So let me do it, and I'm going to mean what I referring to these identities. Okay, so let me copy first and I explain. If I compute sine theta or cosine theta all over sine theta all over open brackets 1 minus sine theta close bracket cosine theta. Okay, this is division or fraction side. All over sine theta. Okay, let me explain. So why I apply the relationship of this one to here? Well, like I said, I'm applying this Pythagorean identity, which is sine theta squared plus cosine theta squared is equals to 1. Since this one is sine theta squared plus cosine theta squared is equals to 1, since this one is raised to power of 1 and this one is 1 minus sine theta raised to power of 1, so no need to write 1, we know that this is raised to power of 1. Okay, why I was get Oh, how did I get this? How did I get this? The relationship? Well, if you minus 1 on both sides, if you minus 1 on both sides, okay, if you minus 1 on both sides, sine theta square plus cosine theta square is equals to 1 minus sine theta square. So not minus but, so now you see if I cancel this, sure guys, no, sine theta square plus cosine theta square is equals to 1. So now I'm going to minus sine theta square on both sides, okay, plus cosine theta square is equals to 1 minus sine theta square. This is wrong. Okay, so this is what I mean about this. Now you see cancel. So cosine theta squared is equals to 1 minus sine theta square. This is what I'm going to apply here. Okay, so which is I apply already. Okay, so let's continue solving. So if I continue, as I said a while ago, this is where I got it already. So I applied a relationship here. So I got this one. So now I'm going to apply this rule. Rule number 4, dividing by a fraction is the same as multiplying by its reciprocal. Okay, so rule number 4 I'm going to apply here. So I'll copy it on top cosine theta all over sine theta multiply by this one go up, this one will come down, as I said, rule number 4, and then sine theta all over, okay, 1 minus sine theta close brackets cosine theta. Why I put it in the brackets? Because it will make sense. If you just write it as it is, it's not make sense. If you write 1 minus sine theta cosine theta, it's not make sense according to math law. So it's better to put the brackets within. So now you see I cancel cosine theta, sine theta is gone. Now I remain with 1 minus sine theta is equals to our constant here, or which is left hand side is equals to sine 1 minus sine theta 1 minus sine theta 1 minus sine theta. Okay, so guys, this is what I make, or I solve it to make it equals to left hand side. So this is our left hand side. Okay, this is our left hand side. So I know that sorry, this is 1 all over sin theta. This is 1 all over sin theta. 1 all over 1 minus sin theta. Okay, because as I cancel this one will go, this one will go, this one will go. Know that according to common sense, my 1 is on top here. So this is where 1 over 1 minus sin theta is equal to 1 over 1 minus sin theta. So guys, this is our final answer for what I did here. Okay, so let's continue another problem, which is problem number 3. Problem number 3 states that open brackets sin theta plus cosine theta close brackets raised to power of 2 plus open brackets sin theta minus cosine theta close bracket raised to power of 2 is equals to 2. So guys, as I said already, this is the difference of 2 squared. Okay, so if I'm going to simplify this down, I need to expand the brackets. In order to expand the whole thing here, it might take a long process. So the simplest way to do it like this: open brackets sin theta squared plus 2 sin theta cosine theta plus cosine theta squared close brackets plus sign, copy down, plus sign, I copy down, open brackets sin theta squared minus 2 sin theta cosine theta plus cosine theta squared close brackets. Okay, so if I simplify down, coffee sin theta. Okay, this one, let me explain again, guys. I'm going to arrange this one again. So if I arrange it, sin theta squared plus cosine theta squared plus 2 sin theta cosine theta close brackets plus 1 plus not 1 but same thing. I'm going to rearrange it same as this one. Sin theta squared plus cosine theta squared minus 2 sin theta cosine theta close brackets. Okay guys, another thing I'm going to explain here again. Okay, what is the relationship that I'm going to use it here? Now I think about this. So let's refer back to our identities. Is once again reciprocal? No. Tangent and cotangent? No. Pythagorean? Yes. Why? Because I'm going to use this one again. Sin theta square plus cosine theta square is equals to 1. So I'm going to use this one to simplify everything down to come up with the final answer. Okay, first I know that my sin theta square plus cosine theta square, which is this one. This is the relationship, remember guys. And cosine theta squared is equals to 1. Okay. So now I know that this one is equals to 1. So now I copy 1 plus 2 sin theta cosine theta. 2 sin theta cosine theta flash. Same here. Sin theta square plus cosine theta square is equals to 1. So 1 minus 2 sin theta squared cosine squared. Sorry, not squared. Okay. Because this one is equals to 1, this one is equals to 1, so I copy 1 down. Relationship for this one. Same as this one. Okay, you see? Sin theta square is equal plus 1, cosine theta square is equals to 1. And I copy down this one, which is I did same as here. I copy down. Okay, you see? Then I cancel now, you see? This is the difference. Okay. 1 plus 2 sin theta cosine theta minus 2 sin theta cosine theta. So now I'm going to cancel whole thing here, whole thing here. So I remain with 1 and 1. So 1 plus 1, which is 2. So as I said a while ago, we need to prove the left hand side is equal to right hand side. So this is our answer. So it's equals to 2. Okay, let's go to question number 4. Question number 4. Question number 4 is this one. Question number 4. Cot theta cosine theta is equals to cosecant theta minus sin theta. Okay guys, let me explain this one again. Once again, I'm going to think twice before I solve. Am I going to start on the right or at the left? For my case, I'm going to start at the left to make everything is equals to right hand side. Okay, let me write. But since our cosecant theta is equals to 1 all over sine theta. Where did I get this? This is in reciprocal identities. Let's go back to our identities. Tangent, cotangent, none. Pythagorean, none. So I choose reciprocal. Okay. So reciprocal, which is this one. Cosecant theta is equals to 1 over sine theta. So I choose this one. Choose this one to solve. Since cosecant theta is equals to 1. Okay, now I'm going to continue. Let's copy down. Cot theta cosine theta is equals to 1 all over sine theta. Copy down minus sine theta. I bring this one down. These are constant. Okay. As we all know, I will start at the left hand side. So left hand side, the relationship of this, which is 1 over sine theta, which is I stated down. This one, just to make it clear so that you guys understand what I'm doing. So now second thing I'm going to do, guys, going to cross multiply. Okay, let's take this one as right hand side. Okay, right hand side meaning this one. Okay, now I cross multiply. Once again, I'm going to apply 1 multiplied by 1, which is 1, keep the sign multiplied by sine, which is sine theta squared, keep the denominator, which is sine theta. Okay, continue. So this is the 1 minus sine theta squared all over sine theta. So if I'm going to apply the relationship of this one, which is cosine squared theta all over sine theta. Why I choose cosine squared theta? Well, let's refer back to our relationship or identities. So I choose this one, as I said in Pythagorean theorem. So, well, why I choose this one? Let me compute this. Okay, to make things clear. Is equals to no, not this one. Sine theta squared plus cosine theta squared is equals to 1. So if I minus sine theta squared on both sides, okay, on both sides, plus cosine squared is equals to 1 minus sine theta squared. Okay, so if we cancel this one, now you see cosine theta is equals to 1 minus sine theta squared. Since this one is equals to this, and I was applying this here. Okay, so since this one is raised to power of 2, so I just give the power to make sense. Okay, so now I continue once again. Now I'm going to separate all things to make simplest. Okay, if I write this one as, I can write this one like this: cosine theta, okay, because raised to power of 2, all over sine theta, which is this one. Keep down. Okay, but or since cot theta is equals to cosine theta all over sine theta, which is our relationship of tangent and cotangent, this one. Okay, then I have to substitute this one is equals to cosine theta over sine theta. Okay, substitute this one. Okay, so now if I state this, which is right hand side, this one I bring down cot theta cosine theta is equals to cosine, not cosine, cot theta all over cosine theta. Okay, because you see this one, we said that this is equals to cot theta is equals to cosine theta all over sine theta. Okay, so this is where I stated down here, and where do I get this cosine theta? Cosine theta is, I shall act from here. Okay, so this one is not sine, this is cosine. Do some mistake. Cosine theta, this is cosine theta, so I just bring this one down, to make everything is equal. Okay guys, so thank you for watching, and God bless you all.